All right, single replacement reactions. So in single replacement reactions, very easy to confuse them with double replacement, and even for some students with combustion, because they have two things in front and two things after. And so do the other two. So single replacement, double replacement, and combustion all have two things as reactants and two things as products. So these are the ones that are easier to confuse, because combustion, different from combination, sounds similar but different. Combination only has one product. It only has one thing after, not two, the arrow specifically. And then if you look at decomposition, it only has one thing in front of the arrow, one reactant. But the other three choices that we have left to cover, they have two in front and two behind. So notice in single replacement, the easiest way to recognize it is somebody is a single. Somebody is by itself. It's kind of like a bachelor or bachelorette. And then somebody else ends up being a bachelor, bachelorette in the end. So it's kind of like cheating or home wrecking. You have this married couple, iron oxide, but then oxygen runs off in the sunset with aluminum. Notice this coupling here instead of its original partner. So it's like we had a married couple and then somebody else. That somebody else comes in and replaces, in this case, the metal, and we kick the original partner to the curb as an element by itself. So in a way, the electrons from aluminum are basically being used to pay off iron to leave oxygen. So it's an electron transfer process. You take the three valence electrons that aluminum has and you give them to iron so that iron can go back to its metallic form. So it'll be a major focus for what we see coming up in 2 weeks for Electron Transfer chapter. In order to know when this replacement process is going to happen, we have to use an activity series, which we do get on the exam. We just need to know how to use it. In the classroom, we have it on the nearest the door, but on the video, we're going to have it on most of our slides to be able to see it. And it just shows us that if you're at the top of this list, you are the best replacement to have. So notice the arrow goes up. Lithium being the best metal replaces all other metals on this list. And ironically, things like gold, things like platinum, things like silver, the metals that humans hold the most dear, those are the easiest ones to replace in chemistry. The ability to be on the top is the metals that are quickest to lose electrons. So this losing electron idea is the focus of our chapter in 2 weeks. Because if you're at the bottom, you're going to lose electrons the least easily. That means you're going to be more willing to gain electrons. So going up is the ability to be oxidized, and going down is the ability of being reduced. That's the major focus for the end of this exam cycle for that chapter coming up in 2 weeks. For right now, just know that you marry up. If you're married to somebody like hydrogen, which is acid, you only want to marry up. So it's no reaction down, it's reaction up. And it's no different in the real life. You know, if you're married to somebody here, you don't want to marry down to somebody, without a job or that's in prison or something like that nature, right? You always want to marry up to somebody that has a better job or, a better way to support you, to help you. So as we look at an example, let's look for that pattern that we saw a few slides ago. We see this A and this BX, and then we see them switch into AX and kick B to the curb. So if you're married to copper, would it be better to be married up to iron? And the answer is yes. So this is what happens when you throw an iron nail into a copper sulfate solution. Notice the copper solutions, so this is here your copper sulfate down here, this blue solution. Notice on the nail itself, we now have copper. So copper is getting replaced by iron. So eventually the blue solution may disappear completely because iron sulfate is not a blue color. But most importantly, the iron on the surface of the nail the iron on the surface of the nail is getting replaced by copper. And we can see that color change on the nail itself. It looks kind of gold instead of gray. And this is an example of the plating process that you see in a lot of gold plating or silver plating or chrome plating of bumpers and so forth. If you're married to acid, how do we know who's going to react with acid? Well, if you're married to acid, remember this is still A plus BX, and that gives you AX plus B. Here B happens to be a gas that bubbles away, so you're going to see this one escape, as we do see bubbles in the beaker reaction here. If you're married to H, would you want to be married up to, say, iron in this case? And the answer again would be yes. You always want to marry up in life, or in chemistry in this case. So notice it fits the pattern. We have somebody by himself. We end up with somebody else by themselves. There's no partners there. There's no charge there. But these were hooked together, and because of that, we had to do some balancing. In this case, we got the iron 2 ion, not the iron 3 ion. It is possible to take some of our nasty acids and throw in very precious metals into them. So for example, if we have a gold ring or watch that we want clean, we can take gold, which is A, throw it into a BX, and have nothing happen to the gold. That's because if you're married to hydrogen, would you want to marry down? And the answer is no. So instead, you're just going to dissolve away or clean away any dirt that happens to be on the ring itself. So jewelry like gold, like silver, like platinum, all of those very good at being cleaned by strong acid solutions because they're very safe. However, if you have a fake ring that's maybe made of iron, maybe turns your finger green as a result or something of that nature, throw it into some acid and sure, it can react like we saw in the previous one, and you can dissolve your jewelry by accident. So be very careful in using jewelry cleaner if you're not sure if your jewelry is real. Here we have no reaction, so it didn't work, and that does happen if you try to marry down. What we're also seeing on this slide a little bit lower is we're taking metals like sodium and calcium. So this is A, here's your BX, here's A, here's your BX. And notice here you're getting AX plus B. AX plus B is the pattern that we're looking for. Most importantly, though, they think hydrogen of water, which is H2O, is acid. So if you're married to water, you're pretty stable. But if you marry way up, you can be replaced by water, and that's because you're moving so high up the list. This is usually group 1 and group 2 metals that are so reactive in water that they can bubble hydrogen gas from water specifically. So these are what we call active metals because they're the most active of all the ones on our activity series. Then we have double replacement reactions. Double replacement reactions is a focus for this chapter, so we're going to cover it in our final video coming up.